So that was year 7 stats. Along with year 7 stats, thanks, you will then learn a couple of more terms. Now this is more venturing on year 8, year 9 stuff, mainstream anyway. Range is the first thing that you learn from year 7 and 8. So year 7 and 8. What does the range mean? Can I please have, let's go with Toby. What's the range again?
The distance between the sample space.
Oh, so close. It is true. Highest and smallest. Okay, so it is the distance within this sample space, but the best way to understand is from the smallest to the largest number, how many values do we have? What's the units, total number of units? So it is the highest value minus the lowest, or largest minus smallest. This measures the possible data. Okay, so it measures how far from the smallest to the largest, what kind of data am I working with? Again, am I working with 10 units? Am I working with 1,000 units? What data am I focusing on? Now from year 7 to 10, this is essentially the most basic form of what we call the measure of spread. Because data comes in a couple of forms. And you don't have to copy this part down. But you can actually do this intuitively. See, if I drew an axis, and I drew this kind of data. Okay? Versus, in one set of data, you can already say that there's a relationship that as one increases, the other one also seems to increase. So if I put in, say, some variables, say this is the hours that you spent studying, and this is your exam percentage, this first bit implies that the more hours you study, the more likely your percentage increases, right? Versus if I did the same thing and I said this was hours and this was percentage of study, what would you take out of this? Yeah, the second one. Very true. So what that implies is that if you studied 24 hours in a day for a week, you can get very high scores, or you may get very low scores. Well, yes, you may get the worst score. So, there is maths and logic there. So what that data implies is that what you're doing there intuitively is that you're looking at the spread of the data. You see the spread. In this one, there is a trend. And it's how far are those data points from that trend, right? And this one, we can see that the trend, it's too random. There is no pattern to it. So we intuitively look at data in terms of how far away they are from each other or how close they are to each other. So range is one of the first ones. You take the highest point and you take the lowest point, but that doesn't tell you everything about the data. You see, in this one, even if I took the highest one minus the lowest one, it doesn't truly tell me the picture, the story. So later on, we start to look at more types of range, but specifically, especially in senior levels, we look at standard deviation. Now this one, I probably won't likely teach you guys, but in a logical sense, it's actually a more study, exactly what I was just talking about here. See, how did you know that the first one has a stronger correlation, as Molly said, versus this one that doesn't? The study of standard deviation is to actually put that into mathematics. You looked at it intuitively, graphically. We can then put it onto paper and numerically. That's what you study, okay? But at year 7 to 10, you don't learn standard deviation, but instead you only use two types. Use range. That's the only form of spread that we got. So we only look at from the smallest to the largest. Then the only other one that brings it to maybe year 9, year 8 is interquartile range. What was interquartile range again? Hands up if you remember. Yes, Marlon. Good. So we got quadrant 3 third quadrant minus the second quadrant. But what does this mean? Oh, sorry, first quadrant. What does this mean? Anyone remember? Inner quartile range, yes, is third quadrant, quadrant 3 minus first quadrant. What does it mean again? The middle 50% of the data. This gives you the middle 50% of data. Now, how did Sean come about to that idea? Let's visualize it. If this is your minimum number and this is your maximum number, your data sits between this range, right? But if you take the first 50%, there's a problem to that. Because this first half, most people don't sit at a 25th percentile. So if I split it up into quarters, most people don't score 25%. And most people definitely don't score 0%. So you don't actually capture 50% of people. You capture the 50% of the lower performing group, which doesn't actually represent the population or the people that you're studying. So, and then same thing if you took the other 50%, it doesn't make sense as well. Most people don't score 100% and the middle person isn't getting 75%. So even though you're saying 50%, you got 50% of the data, it's not truly 50% of the people. So the best measure is then to take 50%, but you take it from that middle part. So you take 50% of people in this group and 50% of the people in the top group, which actually ends up being 25% to 75%. And they gave these names. So your minimum is what they call Q0, or you think about it as like the very first quadrant because you split them to 4 quadrants there. This is Q1. Your median is called the Q2. Quadrant 3 is your 75th percentile. And then Q4 is your top end. All right, so you can see it as like your minimum, the middle of the lower group, to the actual middle, to the middle of the upper group, to the absolute max. That's why there was that Q1, Q2, Q3, because essentially there's just splitting it up into quadrants. And the reason why we like to work with inner quartile range is because we know that most people will sit within the middle, less so on the bottom or the top half. Because as we know, most data, if in a real scenario, most things do turn out to be a bell-shaped curve, meaning most data do sit in that center region. That's why most people sit. And then you get your top end who really outperforms the general group, and then the bottom end who generally underperforms the general group. Okay? So inner quartile range is the next best measure in terms of spread that tells us what kind of data am I working with. Am I working with a very concentrated group of high performers? Am I working with a diverse group of performers? Or am I working with a very concentrated lower performing group? That's what the spread tells us. Okay? So when I say quadrant 3 minus first quadrant, the meaning is, thank you, the meaning is correct, that it is the middle 50% of data. The mathematics to it is you're taking the 75th percentile minus the 25th percentile. And if I had to spell that out in words, I'm really just saying it's the middle person of the upper group. And this is the middle person in the lower group. That's essentially what you're doing. You're taking the middle of the lower group and the middle of the upper group. That's the range that you're focused in. That means the middle person of the entire group must be somewhere in there too. Okay? So that's the middle group that we're interested in. That tells us more information than just lowest and highest. Because there could be a lot of things that's happening in between in the middle versus the bottom end and the top end. That's why we look at that. Okay? And obviously, standard deviation actually breaks that even further. It actually then breaks, what about in between 25 to 50 or 50 to 75? It breaks it up even more. So that's why standard deviation is better measure. But at your level, 7 to 10, we only work with range and interquartile range. Okay? All right. Now that we talked about, well, since 50% is not equal whether you take the lower end and the upper end and we like the middle, then that must mean there is a group of students or people or performers that perform way out of the group that we're currently looking at or way below the group that we're looking at. So we give them a boundary, and then if they pass that boundary, we call that outliers. Anyone remember how or what the boundary percentage is, or how do we calculate the outliers? Yes, Violet?
For both but Q1 makes it 1.5 of 55.
Very good.
Q3 plus 1.5.
Beautiful. Now let's break that apart. You can memorize this formula, which most students do, but if you actually interpret what it's actually doing, IQR, we just said that's the 50% of data. So that's like the most of the people that we're analyzing, we've got that group. That's the range of people they're working with. And what you're saying here is, you're saying, where's Q1? So where's the middle person in the lower half of the group? So they're here. And you're saying, okay, if you perform less, so minus, you perform 1.5 times IQR. What does that mean? 1.5 is not just 100% of this group. You're doing 150% of this group, this middle band, 25 to 75. You're taking the general population and you're saying, I'll do 150% of you, and then I shoot down in the negative direction. So you're worse than 150% of the general group. And if you still pass that boundary, of course you are way too much. That's the boundary. You're not even saying double now. You're saying 1.5 of the general group. That's the standard. Obviously, we can play around with the boundaries, but as a standard, we're saying that you really, if you're overshooting it in that left direction, and the fact that you are much lower than the middle person of the lower group by 1.5, that's 150% from the other direction. That's why we then calculate that as, that's probably too far. Okay, because wherever the general group, that was already a boundary. Now you're 1.5 times that on the left side. So then the upper group is the other way. The upper group is taking the middle person on the top end, and they're saying, well, what if I take the same group and I times by 1.5 and I add it on? That's my upper boundary. Now, if you're way beyond that, then you're so far away from where the general population is, at least whatever we're studying. Okay, so that's why this is actually just giving you a fence or a boundary to say this is either very underperforming or this is very overperforming. Okay, so this additional part is really just saying 150% of the 50% of data. That's what you're really doing there. That's what you're saying. You already had your 50% of data, which is meant to accommodate for all the people most of the people that you're looking for. And then you're taking 150% of that, that's huge. That's an extra 50% of that range, and you're minusing it. So of course, if you're performing less than that, then you're definitely way below what you would expect the group to be. So hence they're an outlier. Yeah. So one is adding. So adding is to see the upper end. And then one is to subtract, is to look at the lower end. Okay, and essentially that's how we then define what is an outlier. So you have to perform 150% less than what the actual group generally would perform. Then it would make sense that you're out of that group. Okay, so you're not belonging in that group. That group, for whatever reason, is different. You're very different from that group. Okay, so that's just a reminder of your year 7 to 10. Essentially, that's what we're going to be doing. Year 7 to 10 mathematics. IQR outliers, and most of year 10 who go to general maths, this is what they essentially study. Okay, it's about breaking it apart and interpreting it in terms of data and then explaining it verbally and written. That's what they do at general maths.
For methods, do you do statistics?
We do more of standard deviation. So we do less on this IQR and outliers, but we spend more time looking at the mathematics to bell curves. So we look more at this one. So how do we draw that function? How do we find the area under this curve? We do the mathematics and calculations for that. So it's a different type of stats, whereas the other group actually looks at the data. So what you're about to do now, that's more of a general mathematics, where they enter the data, they put on their spreadsheet, and then they analyze it and then interpret what it means. Okay? So there's one end where you just do the calculations and the other end is the interpretation. That's, to me, the most challenging for most general students because they can follow a formula, but they may not know what those numbers represent. So learning to interpret what those numbers mean and why that's the case, that's the higher end of general. Okay? All right, team. So let's do an example. So that's the theory that you need to understand and why we're sort of analyzing data and how we're analyzing it. Flipping back up, let's have a look at the example. Grab out your CAS if you have it. Otherwise, you can do this by hand as well. All right. So we've got data. We're going to use... What's this? We use the... Something to sketch box plots.
So, we're going to need our calculators in the exam, right?
Yeah. Univariate means that uni means one, right? Variate means that the variable changes. So have you noticed that the data that we look at, this is a list of numbers and they represent something. So it could be student scores, it could be number of siblings, it could be student attendance in the last 14 days or something. Oh, sorry, in the last month. So whatever this number represents, it's one set of data. It's one set to represent a variable. And that means when you're sketching, it's not a two-way axis where bar graphs, for example, bar graphs require two variables. It requires an x and then a response to it. This is called a univariate because you only got one data, and so you use the one data to analyze. Now with this one set of data, there's two graphs that you can use. You can do dot plots. That's a way to measure one data. The more frequently used one is univariate, and that's the one you see on your NAP plan and all that. So they use the one axis for English, for maths, for whatever it is. It's just a one set of data. Yeah. So univariate means one set of data. That's what it means to sketch box plots. In order to do that, you do need to rearrange your data in ascending order, meaning smallest to largest. For those who don't know what that means, smallest to largest. Now, if you're using a CAS, you don't need to actually do it. If you're not doing a CAS, then you'll have to do it by hand. So you can order that by hand. But we're going to do it on a CAS. So here we go. Go to your CAS. And we're going to go to spreadsheets. Okay, so it's this spreadsheet looking thing over here. So move your cursor down. Go to Add List and Spreadsheet. Press Enter or click on it. And you should be able to get an Excel spreadsheet looking sheet in front of you. Right? We can call this X for now, so I'll call A column X, just because there's only, we don't know what the data represents. Say that's the attendance for the next month or so. And let's enter the data that we got. We got 12, 8, so 12, enter 8, 9, I think it was. Nope, 19, oops, 19, 13, 22, 15, 13, 22, 15. What else did we have? We have 1, 17, 24, 1, 17, 24, 19. I think it was 19 again. Yep. Enter the data. Here we go. 12, 8, 19, 13, 22, 15, 1, 17, 24, 19. All right, there's a couple of ways. Now, if you don't want to sketch the data, which I'm going to teach you how to do it so you can visualize it, and then hence you can draw it. This is what general maths would do. Or you could also just analyze it, and it'll tell you all the numbers that you wanted just now as well. Okay, so let's do the sketching first. So you go to, is it menu? Add? No, it's Control Doc. Do Control Doc so you can add number 5, which is data and statistics. Click on that one. You should have all the numbers that you just entered just now. Okay, so I'll just go back. So if you're on this page, instead of pressing Doc, go Control Doc. So it allows you to add data and statistics. There's number 5. When you click on that, it should come up with, oh, where'd it go? Oops. Data and statistics. And it should look something like this. Okay, yep.
Sorry. If the exercise would be 90 or 90, it's on the textbook, it says 90.
Oh, I think mine might be 9D. Is it not 9D?
I think it's
Oh, is this the wrong one, is it?
The one before is 9C. 9C is meant to be like summary.
Oh, yeah. So I'm doing 9D box plots. 9C, I'm kind of summarizing it in here. One. So we're back on this one. So once you set your data, that's your data, but it's unorganized. What you can do now is you can click on the x-axis because it's univariate. So we do it on the x-axis. Boys, thank you. Don't speak while I'm speaking. Thank you. Click on that because we labeled it X before, so I can now just click on it because I labeled it X. If you didn't do that before, go back to this page. On column A there, I labeled it X there. So if you did that, it should organize the data. This is a dot plot. Okay, so just putting the dots. And we can already see that the most popular or mode is over here. 19 is the mode. That's the most frequent data. But to get your box plot, you go to menu, plot type. Okay, so menu, plot type, which is number 1. And you can see here you got a box plot. So if you press number 2, you should do that. So I'll do it again. So on the x-axis, on here, when it says click to add variable, click on that. If you now labeled it X, like I told you to do before, you just click X and it will just reorganize the data on the number line. Okay, so it does that. Then you go to menu, plot type, box plot, and then you can see an outlier. And that's your one. Yes, they probably use a cross. I think they use a cross for it. That's your minimum, Q0, Q1, Q2, Q3, Q4. Okay? So, here we go. With this shape. Wait, actually, before I move on, can I get a show of hands who were able to get the box plot up? Good. Okay, cool. So that's how you do it. We don't do that in methods. You'll find that it's only in general that they do this more. This is more of a general skill. For methods, we don't actually look at box plots. We actually draw it ourselves if we did do it. But that's if you're interested in how to do that. So I'm just going to copy and paste it over here for those who want to look at it again. But let's say you didn't want to visualize and you just want to enter the data in. You could have clicked on a cell, any random cell. Go to menu, statistics, stat calculations. Okay, so I'll do it again. So go to menu, number 4, statistics. Number 1 for stat calculations because we want to calculate. And because we're dealing with one variable, it's called one variable statistics. Okay, so if you click on that one, number list, just 1, it's fine. This is just telling you where do you want to enter your data from. And I'll keep it in C because I clicked on cell C. And here we go, I'll press OK. Whoops, did I not select it? Sorry, let me select stat collections, one variable stats, number list. Oh, sorry, I was meant to say X. X is my data and I want the result in D column, column D. And this will give us a bunch of data for you to look at. If you scroll down, it'll tell you the min, Q1, median, Q3, and max. So you have 5 number summary stats all in one. For those who are curious, this is your mean. That X bar means the mean. When you're doing the average, oh, sorry, I can't even type mean. Just know that's the mean. This means the sum. You know how you say sum all numbers? When you find the average, that's the sum. This is for standard deviation stuff, so you don't need to know that. But that means the mean. Okay, so in one shot, you can find the mean, you can find the median, Q1, Q2, Q3, all in one go. Have a go, let me know. Hands up if you're having difficulties so I can make sure you know how to do this. Yep.
When I tried to do the use numbers too,
yep.
like all the words are like right.
All the words are right.
Right.
All right, we're resuming. Shh. Listening. Thank you. Thank you. All right, so if you've done that, so you could have done it through the graph. So you can just move your cursor across to look. Voice. Thanks. You can either look at your cursor and then you can figure out minimum, max, min, or you could have analyzed the data. Both ways work. In general maths, they usually do the data first and then they analyze on the graph later. So they do that graph later. Okay? Voice. Thanks, team. I find it highly disrespectful that you're doing something else while I'm teaching and then you're also giggling and speaking. I'm okay if you're doing other work. Sometimes you're doing your debating stuff. I don't mind. But it's highly disrespectful as I'm teaching, you're chatting. Because it makes it hard for me to distinguish who's actually trying to do the work and who needs my help versus who's just mucking around. Yeah, you've got your own things to do, and I get that. But be mindful as I'm teaching. I find it disrespectful when you're not listening. Or if you're not quiet. Okay? All right, so you should have the ability to be able to do the graph, and then therefore you can look at the outlier straight off from the bat. So we can tell it's 1. Minimum is 8. Q1 is 12. Q2, median, is 16. Q3 is 19. And you see the max is 24. If you did it through this way, then you'll see the mean, which is nice. So it tells you the mean. This one is sum of numbers. You don't need to know this one. This is sum of squared numbers, which is if you want to learn how to find standard deviation and variance, you do need that, but you guys don't need that yet. And then from here, you do need, so number of numbers, n is 10, minimum, so that you get the same stats here. This is called your 5-number summary. And the bottom part, again, you don't need. That's to calculate variance, okay? Which is something you don't need to know yet. All right, so those are your 2 ways if you're using a CAS. Otherwise, the only other way is you do it by hand. So in this exercise for Year 10 mainstream, they often do it by hand first. So they learn how to do it by hand. I'm teaching you the calculator section because I think you would have done this last year already. Okay, so I think you've done it by hand, so I'm just teaching you how to do it with the technology. It means that if I did put this in the exam, I do expect that you can do it that fast. Okay, you just put it in, enter the data, and it's probably 2 marks just to get the table right, and then sketch it. Yeah, so I'm not going to expect that you're going to do everything by hand. If you happen to do it all by hand, I know you haven't watched this video or you weren't listening on how to do the CAS work. Okay, so expect if I put this up on your exam that you can do it on your CAS, and it's a quick data entry, not something that takes you 5-10 minutes to do. Okay? All right, other than that, that's pretty much all the lesson was. Drawing the box plot, yes, you do need to measure. So you got to use a ruler to draw your number line, and you do have to label it in scale. So if you were to do this, it has to be to scale when you're doing a number line. Okay, that's the only little detail when you're graphing. Number line, we do normally use a cross for an outlier. Little cross. On your calculator, they use a circle. We do a cross. Okay, so we do a little cross and the number underneath. So what was the number again? It was 1, wasn't it? 1. So make sure that's 1. Okay, and then we do actually have to measure it and write 2, 3, 4, 5, 6, 7, 8. Ooh, that's bad. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I think that was, what was the last? Oh, wow, 24. 21, 22, 23, 24. Yeah, that should be good. All right. Box and whiskers plots. Again, you do have to use a ruler as well. So if you're doing a box and whiskers plot, so this is 8. We use a circle for 8, so it's inclusive. 24 is a circle. What else do you have? 12 is your lower Q1. You do have to rule this one. It has to be a nice vertical line. And what's the other one? I should have done a box, actually. It would have been easier. 19. Is it 12 to 19? Yes, it was. And median was 16. All right. Oh. There we go. That's what they would do in the general math stream. So they would actually have to do this to scale. They do have to use a ruler to sketch the box, and each line is ruled to draw. Okay, it looks like something like that. But if you're not doing general maths, then we don't often do this skill at all. I can't even think of it one time if you're doing methods and special. But that's at least for you to understand. So then from general, on the higher end, it's about then analyzing that data, interpreting it, writing a paragraph to explain what that data represents. Okay? So that's mainly general maths. General maths is about data analysis. How do you interpret the data and what do you do with the data for the first half of the year? The other half is to do with networks and all that, which is really cool stuff. Financial maths as well. Less so on algebra. So what you find this term, it's less so what we did last term. Last term was a lot of algebra, lots of abstract thinking, hypothetical thinking. This is concrete data, and you're interpreting the data is what makes a difference between the two maths. Okay? All right, Tim, that's it. That's exercise 9D from the old textbook or 9E in the new textbook. If you're doing summary statistics, it pretty much was minimum, Q1, Q2, Q3, and maximum. That's your 5-number statistics. So you don't really have to do that previous exercise if you're doing box plots. If you do box plots, it already includes summary stats. Okay? All right, team, that's it for today. I'm going to stop the video.